Good morning, students. I am Navdeep Dhaliwal, faculty of Arya College of Engineering and IT. Today we will discuss our topic Vidicon camera tube. The basic principle of Vidicon camera tube is photoconductivity, where resistance of photoconductive surface decreases with increase in light intensity. Vidicon is short tube with a length of 20 to 12 to 20 centimeter and diameter between 1.5 to 4 centimeter. Resistance of surface changes between 2 mega ohm to 20 mega ohm for bright to dark spot. For bright spot the resistance is 2 mega ohm, and for dark spot the resistance is 20 mega ohm. Now we will discuss about the construction of Vidicon camera tube. The Vidicon consists of a glass envelope with an optical flat face plate. A photoresistive target plate is available on the inner side of the face plate. The target plate has two layers. To the front facing the face plate is a thin layer of tin oxide. This transparent to light but electrically conductive. To another side of target plate is coated with a semiconductor photosensitive antimony sulfide. The tin oxide layer is conducted to power supply of 50 volt. Grid 1 is the electron gun consisting a cathode and a control grid. The emitted electrons are accelerated by grid 2. The accelerated electrons are focused on the photoconductive layer by grid 3. Vertical and horizontal deflection coil placed around the tube and used to deflect the electron beam for scanning. Now working. The working of the basic principle of Vidicon camera tube. The basic principle is photoconductivity. The working principle: light will pass through a glass, and after that light will pass through conductive coating. Now see this conductive coating that is having characteristics like its resistance that will change with respect to intensity of light. After conductive coating, photoconductive surface is also there. See, for conductive coating we will be taking output electrical signal of Vidicon camera tube. Scanning and synchronization. A still picture is fundamentally an arrangement of many darks and light areas. Each small area of light or shade is called picture element. All the elements contains the visual information in the scene. If they are transmitted and reproduced in the same degree of light or shade as original and in proper position, the picture will be produced. In order to produce video signal for all the elements in the picture, it is scanned by the electron beam. One element at a time is sequential order. The scanning is done in the same way as a written page is read to cover all the words in one line and all line on the page. Hence, scanning is the process by which an electron beam spot is made to move across a rectangular area as so as to cover it completely. The rectangular area may be target surface in a television camera or the screen of a picture tube in a television receiver. So here we can see the scanning process. In the scanning process you can see the electron beam is started from top left to bottom right. When electron beam is moved from left to right, it is called trace, and when electron beam move left to right to left, it is this is called retrace. The information is only in trace period. In retrace period there is no information. And the two type of scanning is there: vertical scanning and horizontal scanning. In vertical scanning, the electron beam is moved from top to bottom, and in horizontal scanning, the electron beam is moved from left to right. One by one, all lines are scanned using electron beam. The scene is scanned rapidly both in horizontal and vertical directions simultaneously. This provides sufficient number of complete picture or frame per second to give the illusion of continuous motion. In most of the television system, the frame repetition rate is 25 frames per second. Scanning and synchronization. For scanning the picture element, sawtooth potentials can be used. Sawtooth potentials are produced by using a unijunction transistor and a RC network. Sawtooth potential are applied to horizontal and vertical deflection plates in a TV camera. When the sawtooth potential is applied to the horizontal plates, called line synchronizing pulse. Thus, for scanning the picture, the three synchronizing pulses are used. These synchronizing pulses, along with the output of the TV camera, are modulated on an ultra high frequency carrier and transmitted. The accompanying sound is frequency modulated and transmitted by the same antenna. Interlaced scanning. In India, the frame repetition rate has been standard at 25 frames per second. This repetition rate is enough to cause an illusion of continuity, but the brightness of one frame blends smoothly into the next. Through this time, when the screen is blank between successive frames, this results a definite flicker of light that is very annoying to be observed, where the screen become alternately black and dark. To eliminate this flicker, each frame is scanned twice. Horizontal and vertical frequency. The movement of electron beam spot from left to right and back so as to start a new line in the same direction is termed as horizontal scanning. The horizontal scanning frequency is defined as the number of lines scanned per second. In 625 line system transmitting 25 frames per second, the horizontal frequency is 625 multiplied by 25. This is around 15,625 hertz. Consequently, time taken to scan one line is 1 by 64. Vertical scanning is the movement of electron beam spot in the vertical direction. One frame consists of two fields, resulting into 50 fields per second, with a vertical field scan time of 1 divided by 50 is equal to 20 milliseconds. Thank you.